Experiment is about interfacing a temperature sensor and displaying the value of humidity and temperature. So we are interfacing a DH11 sensor, which includes a temperature sensor module, which is thermistor, and you have a sensor which determines the humidity content, and for that we use a capacitance based humidity sensor. So the DH11 sensor which we are using, you call this as a DHT module, 11 module, has got 3 pins. As we know that this sensor acts as an input device which collects the humidity and temperature happenings in the surrounding. So this one pin, input pin, will be acting as an input port. If I want to interface it with microcontroller, then we've got VCC and ground. So make sure that the supply voltage to trigger this module is given through 3.3 volt, which means pin number 1 is the one which you can utilize to connect it to this VCC. So 3 volt VCC should be given to turn on the system, and ground, you can utilize any ground connection. So this substrate, the moment you dismantle it, you're gonna find the view of this module something like this. It includes humidity sensor, which is based on the capacitance you are gonna feel what's the humidity level content present in the environment, and you have a thermistor which acts as negative temperature coefficient resistor. So it means as the temperature is more, the resistance in this device is gonna be lower and lower, hence we call it as negative temperature coefficient. More the temperature, the resistance across this device is gonna fall down and down, and that will be converted. Its equivalent value is digital value will be holded in this device, which we read it in the microcontroller and we display the result. This is the humidity module, which is like a capacitive based humidity sensor we are using, which means the dielectric which is being placed between these two electrodes could be made up of aluminum oxide, or even you can use polyimide material, which senses the atmosphere, and if there is any water vapor content falling on that, its equivalent capacitance is going to be recorded and will be stored in this device in a digital format, which can be received in the microcontroller. Now to program it, what we need to do is the same one single wire we are using, which is nothing but the input pin. So we need to send a signal from the microcontroller to DHT, which means that pin will work as output port. That implies it's like we trigger this module, you are sending a start pulse. So to make sure that you are sending a start pulse, you need to make sure that you pull down the pin to logic low at the pulse duration should be 18 millisecond. So 18 millisecond should be the pulse duration at which this pulse should go low. Then it has to be triggered out. So make sure that you design a pulse with 18 millisecond low. That means the system is triggered, which means you are requesting the DHT to respond. The DHT responds by sending either 0 or 1 bit. So the way you identify whether it is a 0 or 1 is based on this nature. So initially, the moment you send a start pulse, the DHT responds by sending a pulse back to the microcontroller, which means through this wire you are gonna receive a signal having a pulse duration off time 54 microseconds and on time 80 microseconds. So this kind of a pulse you will be receiving it to the microcontroller, which means your DHT is responding. Once DHT responds, then it's gonna transfer a 40 bits of data, and you need to understand whether it is a bit 0 or bit 1 based on the electrical nature of the signal which you are going to receive, the microcontroller terminal. For example, if the bit is 0, then you are going to get a pulse having a low time of 54 microsecond, and 24 microsecond time it will be high. So this kind of a pulse, if it's been generated through the terminal line, you need to say that it is 0 bit. Similarly, if you are receiving a pulse with the 54 microsecond t off time and t on time as 70 microsecond, then you need to ensure that the bit which you are receiving through that line is a 1 bit. So this way it will send a series of 40 such electrical pulses. It might be 0 or 1. It needs to be decoded by looking at the shape of the pulse duration. So here the 40 bit data will be the one which will be stored in the microcontroller, and this data, in this 40 bit data, the first 2 bytes are meant for holding the humidity value, the next 2 byte is meant for holding the temperature value, and the last byte is gonna give you the checksum. So if you add first 4 byte values, the result will be stored in the checksum. So this way, in case if everything goes fine, then you add byte 1 plus byte 2 plus byte 3 and byte 4, and when you sum it up, the result what you get should be exactly the value of checksum value. So in case if it's not that, then you mean to say that something the result which you get is not correct. So this is how you can verify whether the result which you are getting through the DHD sensor is proper or not. Regard to the programming, so you use a library called Adafruit DHD, which has to be installed, external package it is, and in almost all the Raspberry Pi having an operating system in it, this library is installed. So we mean to say that pin number 4 is a pin, single wire pin, which we are using. So this is GPIO4, which is pin number 7, physical pin number 7, and here we are using BCM mode always. So make sure that while giving the number, this should be a GPIO number, and you need to say that which temperature sensor module you are using. Is it DH11 or DH12? So here we say that we are using sensor module which is DH11. Then we use this command while true, and this Adafruit library, there is a function called read retry, which to which you need to supply the sensor, which means which module and pin number. So the moment you send this and wait for a while, you're gonna get the value of humidity and temperature, which is displayed here in a proper format. So the 0 implies the temperature sits here, the value of temperature sits here, and the value of humidity sits here, and here the 1 is for humidity, 0 is for temperature. You modify it accordingly, this has to be changed. Then the 0 implies you don't use any kind of padding, no fill between the digits. So in case if it's not been used, then you may find a spacing between digits, and this 0.1 implies it's after a decimal point 1 number is considered, and it's a fractional number which you'll be having stored here. So this is the program. So while true implies always the program is going to run. In case if you require, you can add a sleep module. You can call time.sleep1, so that every 1 second it will wait for a 1 second, and the new value of humidity and temperature is going to be printed. So this is a program to interface the DHD module with the Raspberry Pi and get the value of humidity and temperature displayed on your console prompt of your Python. So this is the connection. Okay, fine. So the connection. Okay, fine. The next program is about reading the same stuff here. So here we are using temperature and humidity sensor, that is DH11 module is used. But the thing is, now rather than printing the information on the console, what we do is we just print the result on the OLED which is attached. So here the protocol used for communicating your master with the slave, master is a microcontroller and slave is your OLED. We use I2C protocol for making the connection between, or making the information transfer between the master and slave. So using I2C, either we can have multiple master connected or you can have multiple slave connected. In this case, we assume that we have a single master which is a Raspberry Pi and a single slave which is a OLED connected. And for using I2C, we require two wires, SCL and SDA. So SCL stands for serial clock and SDA is serial data. And this is the frame format of I2C protocol. So basically, if you want to transfer any information from a master to slave, these are the rules which you need to remember. Initially, you need to send a start bit. So start bit is always having the shape something like this. So initially, both SDA and SCL with the help of a pull-up register will be turned to 5 volt. So both are high. So SCL, it's a clock, then SDA will be triggered low, okay, and SCL is also triggered low for a while, so indicating that this is a start pulse. So start bit transmission, this is start bit, make high and 0 for a while, that implies it's a start bit, followed by the start bit. You have a device address, of the slave module. So for example, OLED device address is 3C. So 3C is the one value which sits here from A7, A6 to A0. So 7-bit address of the slave takes the next position. Then we have the bit read or write. So as we are transmitting the data to the slave module, the write bit is 0, W is 0. If W is this bit is 1, then you mean to say that you are reading information from the slave device to the microcontroller. The next bit is acknowledgement. So acknowledgement bit is to provide acknowledgement to the slave device, saying that the device is ready to send the data into it. Then you have a data being sent by the master device. So for example, here let's say that you have 101.01010 data to be transferred. So those values takes the next position. So send the data, then get the acknowledgement from the slave that the information what you have transferred is received properly and it's been displayed on your module. In case if while transferring the data on its segments, if there is something wrong, then you send a negative acknowledgement saying that the information has not been written on the device properly. If it's a positive acknowledgement, then you are sending 0. So this is the frame format of I2C, and this is a program which has both OLED interfaced as well as the temperature sensor connected. So here SCL, the OLED system, which is this, has got 4 pins, SCL, SDA, ground and VCC. So make sure that the VCC, the supply voltage for triggering this OLED is 5 volt. Either you can use pin number 2 or pin number 4. Ground you can use pin number 39. SCL, this pin has to be connected to SCL of Raspberry Pi. So SCL pin of Raspberry Pi is pin number 5 and SDA pin of Raspberry Pi is pin number 3. So connect pin number 3 to SDA, connect pin number 5 to SCL, ground and VCC. Make this connection and as discussed already, use pin number 7 to connect the DHT sensor. Then again pin number 1 of Raspberry Pi can be connected to 3 volt and ground, of course. then the program. So here you define, you are importing from the Raspberry Pi board, you are importing the SCL and SDA pins. Then you use bus IO, that's for calling I2C protocol. Then you use package OLED text. So this is a package which is required, it's a built-in package required for triggering your OLED module. You don't have to worry about understanding the I2C protocol for programming. So you just have to call the built-in function. It will take care of the protocol design is being done using this package. Again, you require Adafruit DHT module, that's for temperature sensor. So here we are using pin number 18, GPIO 18 is used here, or else even if you can write as 4 implies it as GPIO 4 which you are using. So first get the object I2C from bus IO library. You are calling a method called I2C and you supply this to, that's gonna create an I2C object for you. And then OLED requires I2C object that has a protocol information in it, and also you need to supply what's the width and what's the height of this OLED module. So pixel resolution has to be indicated here. So this is width, total number of pixel width, and pixel height is defined here. So this is a OLED text, which again is an object which takes 3 arguments: the protocol define, the width and height you define of the resolution of the OLED module you have to define. Then you write for I in range of 5, so which means we are running this loop for 5 times, and we receive the sensor. The sensor is the DH11 sensor. Pin number is 18th pin, and here we get temperature 5 times. It's gonna be printed and you're gonna get the information displayed in the console. And the same thing if you want to display results, so you can simply rename this print to OLED.text and you can provide the same information. So one thing to remember here, so here instead of using temperature, this is for 0 for temperature, and we use 1 for humidity. Here it's not required because only one object we have whose information is printed, so both cases it has to be 0. And this one implies you're printing the temperature value in first line and humidity value in second line. So this is a function which to be called for printing information on the temperature. So these are the configurations. This configures your OLED. Then you use a function text and pass the message what you want to print it on those LED.